Hi, so what I want to share with you is an interactive tool that I've been working on primarily to share my output from the WRF model, which is a weather research and forecasting model. Now, this initially started as my master's thesis. It was not interactive, and I wanted to make it interactive so that the general population can log in and see different parameters for their respective areas. Sorry. To the left here, we have different layers which represent different parameters or outputs from the model. So here we have T2, which represents temperature at 2 meters. Here we have TSK, represents skin temperature, SST, sea surface temperature, and up here, rain. Now, as I said before, the tool is interactive, and the goal is to have persons and different organizations or entities select the variables that they want to see or the variables that might be of interest to them. So if you want to see rainfall, you can check the box and you can see that the rainfall layer has now been highlighted or now been enabled. You keep it highlighted by selecting on it, so you'll see the name highlighted in blue, and you can click on a particular location and get rainfall for that location if rainfall has been forecasted. To the right here, we can see 0.0. There's no rainfall for that location, at least at this time step. We can skip through the time step to see if rain appears at any particular time. We see some rain out here over Suriname, the darker blue, and you can use the legend. But let's do it with something that is a bit more easy to see. So we'll use temperature at 2 meters. So we can see the legend here. We have a lot of places to the northwest with some higher reds, and if we choose one of those, sorry, again you need to keep the layer selected. If you choose one of those, you can see 35 degrees in these areas here. If we try to focus a bit more on the Georgetown area, somewhere about here, we can see about 32 degrees. So this is the forecast. And important to note, as I said, the parameters or the different outputs are to the left. And to the bottom here, we have a time slider. Now, this is new. I know that Hydromet does a daily forecast up to about 7 days or 5 days, somewhere along that line, between 5 to 7 days, but it's daily, so you cannot see a sub-daily forecast. This is something that still requires a bit of research on my end, but definitely it will be quite useful for us to have sub-daily forecasts, especially for rainfall and temperature, for event planning and just general reduction of the effects of whatever can or may occur during times of adverse weather. Now, just to provide some context and also to show that is not just a random tool with random graphs and random charts or plots. I'll just share some of the slides from my initial presentation. I've taken out quite a bit of the technical aspects and just try to focus on the main points that represent how the tool came about and why I want to continue to work on it. Now, in 2017, this was part of the justification, part of the literature review, as they call it in the science community. Data was taken from an annual report, a global annual report, which is the Center for Research and Epidemiology of Disasters, CRED. And in between the decade 2007 to 2016, as we can see here, globally, there were 162 floods recorded globally. That's an entire decade. And in 1 year, which would be 2017, there was 126 floods. So a clear increase globally in flooding. There were some other statistics to prove that flooding has also significantly increased in the tropics, which is where Guyana lies. Right. And again, without going into too much of the technical aspects, but just to show again the importance of why such a tool and why such studies is important. Is one thing to just say that it is occurring, but it's the next thing to do the actual research and prove that it's occurring and how we can uh, work on mitigating the effects of these disasters.